So what is a data analyst? Well, it is very simple. You answer the business questions using data. In business, we have managers, stakeholders, project leads, and their whole job is to make smart decisions by asking critical questions. So for example, which region is underperforming? Why are profits down? And should we invest here? So there are many challenges in the business and they need quick and smart decisions. So now without using data, they are just guessing. They rely on opinions, gut feelings, and many outdated informations left and right. And there is famous quote from William Deming I really like and use a lot. Without data, you are just another person with an opinion. So that means if your decision process is based on opinions, this has high chance to lead to confusion, wasted resources, and making bad decisions for the business. Now in companies, the data are scattered everywhere. Your data is stored in many different databases. There are a lot of spreadsheets and maybe as well APIs that provides data. So they are everywhere, and the managers of course don't have the time or the skills in order to dive into all those places. So that's why they go and hire an expert, a specialist. They hire the data analyst. So think about it like you are a detective and you start gathering data from different sources. So you go and query the different databases and as well pull the data from the spreadsheets and the different APIs. So you have to go and get the data wherever they live. So now of course all those data are messy and you have to go and clean and structure those data. So maybe you're gonna go and put the data everything in one spreadsheet like in Excel, and you start doing a lot of stuff on the data, cleaning up the data, organizing it, doing a lot of calculations, transformations to get the data ready to answer the business question. Now after you find something meaningful from the data, you start turning the data into insights, into a visual report, because it is way easier to communicate the result to the stakeholders and managers using visuals. So that means once you are ready, you go to the managers and you start presenting the result as a story using the report and visuals that you have prepared. Now the managers got facts, and this time they have answers to their questions using data. So now they are more confident and they make better and smarter decisions for the business. So now you can see clearly what the data analyst does. He or she is the bridge between the raw data on the left side and the business on the right side. And all what he is doing is answering the critical business questions using the raw data. And as well, it is very clear which skills this analyst needs. So as we understood first, you will be querying the databases in order to pull the data, and in order to talk to the data and the databases, you use SQL, or sometimes we call it SQL. And we have understood as well, once you collect all the data, you will be using spreadsheet like Excel in order to clean, sort, filter, and do calculations on the data. So they have to master Excel, and after analyzing the data using the spreadsheet, you need a data visualization skills using tools like maybe Power BI or Tableau to create charts and clear visuals to be reported to the managers. And of course, one very important skill and crucial, you must clearly understand the business questions from the managers and communicate the results and the findings very effectively. So you have to master this skill. You have to tell a story behind the data. So you need really very good communication skills. So that means if you master those skills, you will be an amazing data analyst that can help the company and the managers making the smart decisions. And now my friends generates big data, and it's gonna be really hard for the data analyst to manually extract the data for analysis, because you're gonna need a lot of data and your request gonna take like hours and even days to get the data, and it might crash and it's gonna be sometimes impossible to get the data. So it's gonna be for you as a data analyst really hard to answer any questions, and your process is gonna take weeks until you give any answers. And of course, managers cannot wait for weeks in order to get like an answer. So my friend, this approach will not work. This is simply does not scale. So now we have to go and scale things and hire new people. Now a data architect, it's like an architect of a building. You have to design the blueprint of a scalable data system, and you have to go and organize the data into multiple layers. Like for example, the Mendelian architecture, you have a bronze layer for the raw data and a silver layer for a clean data, and a gold and very important layer for clean, structured, and optimized data. So all what the data architect is doing is designing this scalable data system. So now as you can see, the data architect is designing this scalable data system, but as usual, they are not the one that is building it. For that, we need another experts, and we call them the data engineers. So now as a data engineer, you're gonna go and build something called data pipelines. Well, it's all about to connect to multiple source systems and start automatically moving the data data from the sources to the new data system. And as well, very important, the data must move quickly. So the pipeline is gonna bring the data to the first layer, to the bronze layer as a raw data, nothing fancy gonna happen here. Then the data engineer gonna move the data to the server layer, and there the data get cleaned, structured, and prepared for the final layer. Now in the final layer, the data engineer gonna go and build a data model, which is highly organized and optimized model that is perfectly made for quick analysis. And we have with that a process that runs automatically from the source systems until the final layer, and this runs every day very fast and in some scenarios as a stream, like a real live data. So remember now our data analyst friend. So now thanks to the data architect and the data engineer, analyst's life now is way easier. No more nightmare of pulling the data manually from the source system. No need anymore for the spreadsheets and the Excel lists. Now everything is prepared for the data analyst to be fast. As a data analyst, once you get a question from the business, you can go quickly and straight away to the code layer where everything is prepared. And now using SQL, you will be querying the data model in the code layer in order to explore and try to find answers for the question. So once you find it, you will go and build again like a visual report and tell a story for the managers. And with this setup, you only focus on what matters, on finding answers for the business. And this can speed the whole process for you, and you will be ready to answer quickly the question. And your answers are always like one-time reports. But what can happen for sure is that one of your reports gonna deliver really an incredible value, and it is not just useful for once and only for the managers. Many people across the company gonna be interested in these reports. So you're gonna have a new user groups that gonna ask you one question. I want your report every day.
No! God, please, no! No!
And the nightmare gonna come back where you have every day to run the same query and generate the same reports, and you're gonna daily send these reports to the users. And this gonna be total waste of your time and gonna build huge stress on you. And that's why companies gonna bring another person to the data team, and this time we're gonna have the business intelligence developer or BI developer. So once the BI developer joins, you as a data analyst gonna say, hey, go and automate this report and make it visible for many users. So first the BI developer gonna build an environment like a server where the dashboards and reports gonna live. This must be secure and has an access management. Sometimes you cannot give all the data for everyone in the company. And as well, this server must be accessible 24/7. So the reports and dashboard must be always available. So once the reporting server is there, the BI developer gonna take everything, the report, the logic, and build from it something called interactive dashboards. And what is very important, this dashboard gonna be automatically connected to the gold layer, to the data model. So that every day, and this is important, the dashboard and the reports gonna get fresh data from the data system, from the gold layer. And once everything is live, the user is gonna go and start requesting access to the reports and start accessing the dashboards and the data. Everything is highly automated and scalable. So the data gonna flow from the sources into the different layers of our data system, and as well automatically flowing to the reporting server and refreshing the data there. So this is the big differences between the data analyst and the BI developer. The data analyst is the one that is bringing the first report and insights, and once a visual or a report gets very important, the BI developer is the one that is responsible of making this report accessible, scalable, and every day available for many users. Now, so far we have helped the business and the managers with questions that are about the past and the present. What happened? How much did we sell? Why did sale drop? But at some point, the manager's gonna ask bigger questions. Questions about the future. What will happen next month? Can we predict which customers might leave us? What can happen if we change our pricing strategy? So they are advanced questions about the future, and to be honest, the data analysts don't have the tools in order to answer them. And for that, we need another expert called the data scientist. The data scientist is the one that's gonna use the data in order to build and train models. They're gonna do a lot of experiments. So at the end, the scientist gonna use this model in order to give answers for the future. So with that, the managers are not just informed, they are as well prepared for the future. They are proactively making decisions, they stay ahead of the competition, and as well, they tackle challenges before they even appear. Now, this type of work is very important thing not only for the managers and project leads, leads, this is important for everyone else. Now this model, this work from the data scientist must be visible for other users. And this is the same thing that happens before, right, with the BI developer. But now we need another type. We have the machine learning developer, ML developer. So now what they're gonna do, they're gonna as well prepare a server and environments to run and deploy the model from the data scientist. So they're gonna go and put it in productive environments, and everything gonna be now automatically secure, scalable, and available 24/7. And the result of this model could be presented in like an application to show the result of the predictions for everyone, or as well sometimes they show it in dashboards and reports. So their job is to make the result of this model available in many services in the company and accessible by other users and built by the ML engineer. And with that, everyone from the managers to teams across the company benefits from advanced predictions every day and anytime. So now by looking to this, everything is highly automated. The data can flow from the sources to the data system and then flows to the reports and dashboards, and as well automatically flow to our model that is trained from the data analyst and built from the ML engineer. So this is what a modern big company built. They build scalable data system. Now if you look to this, you can see there is a pattern. You can see the data architect is working closely to the data engineer to build the data system. The data analyst works as well closely to the BI developer in order to build this reporting system, and the data scientist together with the ML engineer, they work on building an advanced analytical system. And there is actually another pattern. You can see in those roles there is always somebody is like doing a design, like the data architect is like designing the data system, and the data analyst is like building the first version of the reports. Same thing for the data scientist. He is the one that is experimenting and training the first version of the model. So those one are always like trying to discover, trying to put the blueprint. And now in the other side we have the other category. You have the persons that are building it, bringing it to a productive, scalable environment and making things live. Like the data engineer is the one that builds the data pipelines and this data system. The BI developer is bringing the reports and dashboards into scalable and productive reporting system, and the machine learning engineer is the one that is bringing the model and deploy it into a productive system and offering the results in different services. So they are the engineers, they are the developers. So this is what a real modern data team looks like. Alright, now the story with the data always starts with a problem in the business. So we have a business question like, for example, how many customers do we have in the last quarter? Now, of course, it is a smart thing to ask the data instead of having gut feelings about the problem. That's why we try to get the answer from the data, and for that we hire the data analyst. So now the data analyst is going to open their tools and start pulling the data from different sources, maybe from the sales system, customers database, and product logs. And of course, they are in between many steps, but at the end the data analyst is building a report, a dashboard, using BI tools like Power BI or Tableau. And of course, using visuals, it is always easier to deliver the message and the story behind the data for the business users. And now once everything is ready, the data analyst is gonna go and present the result for the business users. But now this is gonna scare everyone. The trends is going down, we are losing customers in the last 3 months, and everyone starts to panic. And now what's gonna happen? Of course, one of the managers gonna ask a very important question. Can we predict how many customers are going to leave in the future? So which customers are likely to leave, so that we can take an action maybe in order to prevent that. And now if the managers go and ask the data analyst about the predictions, highly likely you will get an answer like this: well, I have only Power BI, I can only show you the data for the current situation or the history, but I can't make something very intelligent in order to predict things in the future. And my friends, exactly for this scenario, as we get more complicated and advanced questions, we need a data expert, a data specialist in order to solve this problem, and here comes the data scientist. So that means if the business question is all about the current situation or maybe the past and the history, then we need a data analyst in order to do something called descriptive analysis. But now if the question is looking to the future, then we need a data scientist in order to do predictive analysis. And of course, this type of analysis, it is way more complex than the descriptive analysis, and for that we need like an intelligence system. Using tools like Power BI, Tableau, SQL will not really help. So now let's see how our friend the data scientist gonna solve this problem. Now of course, for each problem we need always data. That's why the first step is to collect the data. But now this time the data scientist needs way more data than the data analyst. So anything the company is generating about the customers gonna be important in this phase. So the data gonna get extracted from databases, logs, spreadsheets. So everything that is related to this issue gonna be collected in one place. So now of course all those sources speaks different languages and they structure and store their data differently. So that means that the data stinks, the data is chaotic, and it's time to get hands dirty. So that means in this phase we are doing data preparations, or let's say like pre-processing. Like for example, we can go and merge those files together and the sources using joins, and we have to check the content of the data. If there are a lot of nulls, we can go and replace them with something more meaningful. And another thing that we can do is that we can correct the data types, maybe remove the duplicates, maybe they are like columns that are totally useless. Now this step is really time consuming, like you spend 70% of your total projects only doing those stuff, only cleaning and preparing the data for the next steps. And of course, if you are lucky and have a data engineer like me in your projects, then we're gonna go and prepare all those stuff for the data scientist, so that the data scientist only focus on the next steps. But you don't have this luxury in each company, that's why mostly you'll end up doing those stuff. Alright, so with that we have now a perfect data set that is clean, structured, and ready for the next steps. And now you might get excited and say, yes, now we're gonna go and do some magic, some AI and machine learning, right? Well, I have to stop you there. Before we touch anything about machine learning, we have to do something very important. We have to explore and understand the data. So we have to do something called exploratory data analysis. So what we're gonna do, we're gonna go and open our notebooks and start asking questions, like for example, how the data is distributed, how we can cluster the customers, is there like any outliers, what are the relationship between like different measures. So with that you are exploring and understand the content of the data, and this is something that we will not go and share with the stakeholders. This step we do it for us, the data scientist, in order to understand the data. It's like doctors, they read the charts before doing any diagnosis, right? So it's like a thinking phase. You look at the data, ask questions, and make notes. So now once we have a good feeling about the data and we feel confident, we can move to the next step. And the next one is very powerful, but yet very underrated. Sadly, a lot of data scientists skip this. Now the scenario is like this. The dataset that we have is, yes, clean, prepared, but the data itself, it is very raw. It is not yet like an information. Like for example, you could have a column called the sign up date of the customer. Now this is very raw. Instead, we can make like an extra column. We can derive a new column and we calculate the days since the sign up. So that means we are creating new columns. We are deriving informations from the raw data, and we can create other measures, like for example, the total spent by customers, the average session duration. So we are deriving smart columns that don't exist on the original dataset. And of course, they are not easy to create. You need some domain and business knowledge. That's why we have done the EDA phase, right? And this is very important. I really don't get it why some skip this phase. The quality of the features that you add to the dataset gonna decide really the outcomes of your work. So this is what we mean with the feature engineering. We are deriving important informations from our raw datasets. And now, my friends, with that we have everything. We are ready and it is magic time. So it is time to do some machine learning. So now the first step is that we're gonna go and split our datasets into two sets. The first one is the training set, where our model gonna learn from, and the second one is a smaller one, the test set. We're gonna use it in order to test the performance, the output of our model, because if you train and test at the same datasets, basically you are cheating. So we don't do that. We split the datasets. And now the next step is the most important one. We have to choose an algorithm. An algorithm, it's like a set of mathematical steps that describes how to learn from data. So basically this is completely mathematics, and what we have to do is that to understand those algorithms, because we have many different algorithms and we have to pick the right one for the right problem. So now once you pick this algorithm, the next step is that to go and apply the training datasets on the algorithm. So now we are combining mathematics with data. So the algorithm gonna go through all your data and start learning from the datasets, and this is what we call, my friend, training a model. Now that means the model gonna start learning the patterns. It's gonna go and find connections and relationships between the data, and it's gonna start adjusting itself as well to minimize the errors, so that at the end we get something very powerful called a trained model that we could use in order to do predictions for new data. Now the output of this trained model gonna be predictions. So it could be like, yes, the customer is likely to stay, or no, this customer might leave soon. So we are labeling each customer, or we could have like percentage on how likely the customer gonna leave. Now, of course, we have to share now this knowledge to the business users. What we could do, we could import everything, the data and the predictions in Power BI or Tableau, and build again like a visual in order to show the final results. So as you can see, it's always a nice thing to communicate with the business users using BI tools, because they are very friendly compared to maybe like visual inside your notebook. So now we go and present the results for the business users, and now they have more understanding what could happen in the future. Now next what's gonna happen, they're gonna plan actions. So maybe they're gonna go and launch retention campaign, or maybe send new offers to the risky customers, or maybe the sales team gonna go and reach them directly. And this is the most beautiful moment as a data scientist. You see, you are adding value to the company. You are not just building like a fancy model because you could. You are really helping the business to see what is coming and to do something about it. Or should not run locally at your notebook. We have to run it on servers, for example, in the cloud. And of course, what we can do, we can use APIs in order to connect internal applications and systems in the company to the model in order to show those scores at the front end. So the whole thing is all about to bring everything that you have done manually at your notebook and to deploy it to professional platform that is fully automated, scalable, highly available and secure, and connectable to different applications at your business. And if you are lucky enough and you have ML engineers or ML ops, they have to do those stuff. So as a data scientist, actually this is not the thing that we do, but if you don't have them, then you have to do it in your own. So now, my friends, everything that you have just shown, like collecting the data, preparing the data, training the model, this is what we call classical machine learning process.